Okay, Assalamualaikum and very good morning. I'm an ex-student of UKM, now working at UMP, Muslim Malaysia Pahang. Just a little bit introduction before we look into the slide. And Prof. Sharum is my lecturer. Just to let you know. He's not here. Yeah, isn't it? No. Okay, so this is my slide. My title is Investigation of Modified Stud Bolt with Optical Sensors for Flange Health Monitoring. I'm stressing on the optical sensors because currently we get used to the electrical based sensors, but now I'm going to introduce the optical sensors. Alright, so let's move to the first, next. So, oh, sorry. Oh, yes. Oh, thank you. So my subject for the testing is the bolted flange, which is I'm building a small scale flange in the lab. So we're going to test the modified stud bolt with embedded optical fiber sensors, so that we can see real time what happened to the bolt during any loadings, any kind of loading, tightening, loading during the application, and so on. So a little bit introduction. So usually we know that we have a lot of methods for the preloading, or we call it axial preloads for the bolt during the application. We have vision based method, we have impedance electrical based method, commonly used ultrasonic method. I think in Petronas they use ultrasonic method to check the loading, the preload, that tightening torque for the bolt, for the flanges before and after and during the inspection. And the last one, we have a newly adapted sensor, which is the optical fiber sensor. So the optical fiber sensor is like alternative for the current, because they're complaining that using offline method to check the bolt is costly in terms of the time. So we're going to find out whether we can use a real-time method so that we can see the loading or the stress that experienced by each bolt during the application. So we have three. I stressed out three methods here. The first is they use embedded sensors inside the bolt, and then the one we have a smart bolt. They build a smart bolt, and the other one, the last one, is they improvise that smart bolt into they put some kind of temperature compensated. I'm showing you the existence not in the market, but is actually in the lab. They find these things as a smart bolt. The first one you see, there is a bolt here. They drill a hole and put the sensors inside. This is the old one. I think this is 2002 research. And then this one, the latest one. So they put a screw, like make a thread, another screw inside the bolt. So that in here they embed sensors. So these are wires here. So this one, according to them, can measure real time what happened to the bolt during the tightening, during the application, and so on. So this is actually one of the modification of this one. They put temperature compensation, because I think not many know. I think everyone that in this field for optical sensors, they know that optical fiber sensors is actually they have influence in terms of temperature. So they need to find out how to get rid of the influence of temperature. They need to use a temperature compensated method. So this is one of the methods they use. They put another sensors to normalize. To take out, to subtract the effect of temperature. So this is the advantage of the FBG. I didn't mention what's FBG. The fiber bragg grating. Maybe some of you know, maybe not. So fiber bragg is an optical fiber. Bragg is a name, as somebody names that invent these things. So these are all these I highlight of the advantage. Immune to electromagnetic. So we have no more worries on the electromagnetic interference. It's very lightweight. For me, I think the best way is this one. You have the ability to multiplex. Ability to multiplex means you can put thousands of sensors in only a single line. Imagine that you have like 1,000 is to exaggerate a little bit. I mean, we put like if strain gauge, one strain gauge, they usually connect to one device to measure the strain. But this one, imagine that only one device you can put in series like 100 okay lah. 100 sensors in one series connect to only one device, single device. So we only need to invest in terms of the cabling and then the device lah. So I think this one very interesting for the application, for Petronas, for the TMB, for the whatever lah, monitoring company. We have FBG company there. You can visit from HBM. You go visit them. Okay, so next, so objective this one is to make sure that when I build this boat, I can test in the actual flange. So, okay, this one you can Google this one. This actually I want to show this. This is actually the sensor, very small, very tiny sensors, very small, very tiny. I think smaller than our hair, smaller than our hair. And then what we do is this is our start bolt. We drill some kind of drain here to make sure that we can put the sensors over here, and then just tightening as usual in the flange. Okay, so this is actually the arrangement of the bolt. Okay, so we have B1, B3, B2 and B4. So we put a force here, try to apply force to see what happened real time to the bolts. I think we put tightening torque is 70 Newton meter. I'm not sure. I think you can refer to my paper. I think 70 or 40. I don't remember. But we do this. We put a load cell here to measure the force, and then what we find is this is real time. Bolt number one, bolt number 1 and number 2. Number 1 and number 3. This one is actually like neutral line because it's in the middle. I think I exaggerate the angle. So it's supposed to be like 15 degrees. 15 degrees is quite small. It's actually near to the normal line. So you can see there's a little bit compression felt by the bolt, but at the B2, this one B2. This one B4. Before feel the tension, positive strain, tension. So this one before, the tension, and this one is compression. So in real time, they can show actually the stress felt by the boat. Okay, and might be the issue in terms of when I drill the hole to the boat. I think might be an issue with that, but subject to the research lah. One PhD student can learn, can study that one. Okay, conclusion. As a conclusion, that we try to make sure that we put a sensor in the boat, and then we find in real time what happened to the boat. There's another project which is we study the tightening torque, and we also change the location for the sensors, and so there's something going on, a lot going on in our lab. So this is one of the things that we want to present here as a support to the SDMMS. So saya boleh buat public semua. Okay, so acknowledgement. So it's my grant. So okay, I think that's all for me. So thank you very much.
Thank you. Like to open the floor for question and answer.
What exactly?
Yeah.
Sensor is measuring.
Okay, sorry. That's a great question. I didn't mention in my slide. Actually, because I skip this one. Okay, so this is actually the equation for the sensor. What they measure is actually they measure strain. Okay, linear with the strain, and also temperature. So in the value that we measure, they can find the strain and then the temperature. But we assume that in the lab we put in the tidak ada perubahan like aircon apa semua kan. So tak ada perubahan suhu lah. So tak ada perubahan suhu maksudnya kita boleh measure strain saja. Okay.
So that is method that we normally use to ensure tightness of the turbine flanges, for example. I think the new thing here is that it's done online,
Yeah.
which is very good.
Yeah. Promising for the moment. For the moment.
Okay, my simple question is, when we drill the sensor,
Yeah.
does it affect the strength of the bolt?
Yeah, that's a controversial. When we modify the bolt, there's a lot of controversial. The question might be asked by the standards or so on. So, if we can prove that we modified the bolt, doesn't give any bad things to the bolt, and then I think we can make it as a policy lah, as a new standard ke. But we prepare ourselves to make sure that this available first, and then subject to the other studies lah. Okay.
It's very small, right?
Yes, very small. Very small.
So, like that, my boat will have few wires pointing out.
Yeah, yeah.
Tak kena pasang dekat turbine, so ada banyak wire lah.
Di sebenarnya gini. Okay, that's I think one of the good question actually that we people asked about the sensor. So this is actually the wires, only this one wires. So we have actually this one ada, kita akan pasang connector macam ni, like this one. Oh sorry. So we have connector here. So just plug in je. Whenever you want to measure, just plug in. So it doesn't matter where you put that one. You just install the bolt, and then whenever you want to measure, just plug in the cable. Then you can measure. If you want to put it as a real-time monitoring, just make sure that you have to manage the cable properly lah. But the cable is very small, very small, very small. Kalau kabel tu tak, bayangkan ni apa, Unify kan, yang ada banyak dia kabel tebal putih kan, dalamnya satu single kabel je, iaitu kabel optic fiber. Imagine that one lah, imagine that one. Tapi sebenarnya memang tu pun kabel kita, memang pakai kabel tu lah. Kalau saya beli pun tu lah kabel je.
Kalau vibration ni, strain boleh measure lah, right?
Yes, betul. Yes, we build our own accelerometer using this one. Itu subject to another presentation lah. Kena subscribe lah. Saya punya channel ada, nanti boleh. Itu video pun untuk channel saya ni. Visit my name, Hafizi FBG, and then you can find videos from me. Yeah, I mean, it's real. You can go to YouTube and find Hafizi FBG, and then you can, find my videos. Okay? Thank you very much. Okay.
Dr. Hafizi, can you stay for a while?
Oh, yeah.
I'd like to present the certificate
Oh, okay.
for your presentation.
Okay.
We start from Dr. Hafizi.
Thank you very much. Okay, thank you very much. Okay. All right.
Thank you.
Thank you very much.